Hello, algebra students. Mr. Lawrence here, and this is the last video on a large scale I'm going to make. Again, nobody has sent me any requests for a small, quick question video. But anyway, here we go. It's all about topic 9, graphing quadratics. Now, at the end, I'm going to do something that's only for the honors students. And so if you are not in my 7th period class, you can stop watching at a certain point, and I'll let you know when that point is. All right, so graphing quadratics. First thing I need to do is find the vertex, right? I'm going to find the vertex, and I find the vertex by doing x equals negative b over 2a, right? That gives me the x coordinate of the vertex. Well, I got to find a, b, c. Easy as -1, -7, -6. All right. And now that I did that, I can find the vertex. So I'm going to do the negative of -7, which would be +7, over -2, which means it's -3.5. Now that's only the x coordinate of the vertex. That is not the vertex, right? That is only the x coordinate of the vertex. By the way, I just found the axis of symmetry, didn't I? Yeah, the axis of symmetry is not -3.5. It's x equals -3.5. Right? An axis of symmetry has to be an equation. Now I have to find the y-coordinate, and that's pretty easy to do. All right, so I'm going to go to my graphing calculator here, and let's see. Okay, so I am going to substitute in, let's see, it was the negative of 3.5 squared minus 7 times 3.5, and then minus 6, I believe, was the equation. Now, I'm just going to go back and double check, because if I have a mistake there, of course, yep, I do have a mistake. It's going to be -3.5. Good thing I double checked my work. So I'm going to go back, and I'm just going to insert a negative. Oop, too far. I guess I can do this one first. And so I'm going to go second, insert, negative, and then second, insert, negative. And now I'm going to hit enter, and there's the y-coordinate of my vertex. So I know that the y-coordinate is at 6.25. Okay? Now, I also need to find any and all zeros, right? Any and all zeros. Well, to do that, I use the quadratic formula. But before I do that, I might decide to check the discriminant. That'll tell me how many zeros I can expect to find. b squared minus 4ac. So b squared is -7 squared minus 4 times -1 times -6. And so I'm going to get 49 minus 24, which is going to equal 25. Now it is a perfect square, which only means it can factor. The real important part is that if the discriminant is greater than 0, I get 2 x-intercepts. If the discriminant equals 0, I get 1, and if the discriminant were less than 0, I would get no x-intercepts. So now that I know I have 2 x-intercepts, I'm going to go to the whole quadratic formula. X equals the negative of b plus or minus the square root of the discriminant. I'm not going to waste time rewriting down b squared minus 4ac. I already know that it equals 25. All over 2a. All right, so I'm going to have x, the 2 x-intercepts are going to be 7 plus 5 divided by -2. And x is going to equal 7 minus 5 divided by -2. Where did I get the 5 from? Because the square root of 25 is 5. So it looks like it's going to cross the x-axis at -6. And again at x equals -1. So I'm going to put those in my table. Let's see, -6 is going here. And -1 is going to go there. And I know the y-coordinates. How do I know? Because they're x-intercepts. So I'm going to have -6, 0. Right there. -1, 0 is going to be there. And then the vertex is going to be at -3.5, 6 1/4. Hey, what do you notice about this parabola? It's going to open downward, isn't it? Yeah, how did I know that? Well, I knew that because A was negative, right? Okay, now I like to get 2 other points on here just to make my graph work really well. And I think I'm going to put 0 in, because when I put 0 in for x, I get -6 out. I can do that math so quick. Ah! My famous airliner, as Jared Dietrich calls it. All right, now, to use symmetry, if I go 1 to the right of -1, -1 is at 0, right? And I go 1 to the right and I go down to -6. If I go 1 to the left, I'm going to have to go to -6 as well. So, whoa, come on back. Come on back. A little bit more. All right, stop. There we go. Now you can laugh at me and my parabola drawing skills. It's only with my airliner. But my parabola is going to look something like this. Try to make it as U-shaped as possible, not a V. Something like that. Okay, you can do a much better job with freehand than I can on the airliner. All right, this one here. Well, let's go find the vertex. Let's list A, B, and C. So I'm going to list them right here. A, B, C. Easy as 1, 0, 4. How do I know B is 4? Because there's 0 x terms in it. There's an x squared, there's no x's, and there's a 4. Now that means the vertex is going to be at 0 over 2, or better yet, 0. So the x-coordinate of the vertex is going to be really easy to find. And I'm going to put my table, input-output table right here, I think. X and Y. Okay, vertex is going to be smack in the middle. And it looks like it's going to be 0, 4. How did I get the 4? I plug 0 in for x. Now, by the way, the axis of symmetry is going to be the line x equals 0. Okay. So, there we go. I'm going to draw the axis of symmetry in on this one. That's what I'm doing, in case you're wondering. Now, I know this parabola is opening upward. How do I know that? Because A is positive. So it's got to open upward. Now, remember, the axis of symmetry is not actually a part of the graph. Okay? It's not a part of the parabola. It's just symmetrical about that line. All right, let's go check the discriminant. B squared minus 4AC, and I'm going to get -16. I can't take the square root of a negative. This will not cross the x-axis. So there are no zeros. There are no x-intercepts on this one. The vertex is going to be at 0, 4, and this guy is opening upward. He's never going to cross the x-axis. So how do I get my other values? Well, maybe I'll plug 1 in, and then I will plug -1 in. So if I put 1 in, I think I get 5 out. 1 squared plus 4 is 5. So 1, 5. And then due to symmetry, I'll put -1 in. I know I'm also going to be at 5. Now, if you want to include 2 more points, well, we could put 2 in. 2 squared is 4. Plus 4 is 8. And if I put -2 in, I'm going to get 8 as well because of symmetry. And so I'll have points here and here. All right, and draw my parabola. Whoa. I think I have an easier time with the downward ones than I do with the upward ones. All right. So there we go. Right? Okay. That's it for graphing. If you need more help on that, let me know, or go back and check out an old video or Khan Academy or whatever it takes. All right. Solving quadratics. The first way to solve is the quadratic formula, right? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's check this one out here. number one, I got to make y equal to 0. Yeah, I got to make it equal to 0. I can't solve for x-intercepts if the y-coordinate is not 0. So I don't know if I left myself enough room to do this, but let's see if I can here. So I'm going to get x equals the negative of b. Oops, it's going to be plus or minus the square root of b squared minus 4ac all over 2a 24. Okay, so now I'm going to go to a calculator and figure out my discriminant, because that's going to make it a lot simpler. I'm going to get negative just about 11 squared minus 4 times 12 times negative 15, and that's going to equal 841. All right, so x is going to equal 11 plus or minus the square root of 841 over 24. All right, so at this point I can go to my calculator, and I'm going to do 11 plus the square root of 200, no, it's not 241, it's 841, excuse me, 841. I'm going to put that in parentheses and then divide it by, oh, is it 24, I think? 2a, 24? Let me just double check, because if I have that wrong, I'm going to get the wrong answer. Yes, it is 24. And so I hit enter, and there's one of my answers. About 1 2/3. Not about, exactly 1 2/3. To get the other answer, I'm going to just go over here and make that plus a minus. Minus. And there we go. And there it is, negative 3/4. All right, there are my two solutions. 1 2/3, 0, and negative 3/4, 0. All right, now for the other problem, same thing, except it doesn't equal 0. So I am going to subtract 12 from each side. And when I do that, I get x squared minus x minus 12 equals 0. And so A, B, and C. A, B, C. 1, negative 12. All right, so x equals negative b plus or minus the square root of b squared minus 4ac. Might have been smart to figure out the discriminant ahead of time to know how many solutions there would be, right? If the discriminant was 0, I know there'd only be 1. If the discriminant were below 0, I would get no solutions. In this case, I think my discriminant is going to be all over 2a. Going to be 49. Yeah. So when I do this, I'm going to have 1 plus the square root of 49 divided by 2. So that's going to be 1 plus 7, which is 8. So x is going to equal 4. And then 1 minus 7, which is going to be negative 6 divided by 2, which will be negative 3. And there's your two solutions. All right, now, on a problem like this, on these two, if they're equal to 0, got to make them equal to 0, you can use the quadratic formula, certainly, but you can also use equation solving skills. They're both binomials, right? And so I'm going to take 9x squared, and I'm going to add 36 to each side. Add 36, and so I'm going to get 36. I'm going to divide by 9, and x squared is going to equal 4. Then I'm going to take the square root of both sides, plus or minus, and so that x is going to equal plus or minus 2. Okay, if I use the quadratic formula, I would get the same thing. All right, over here on this one, it gets a little harder. I'm going to have 5x squared equal to 2, because I'm going to add 2 to each side. Then I'm going to divide by 5. X squared equals 2/5, but then when I take the square root of each side, I'm going to get the square root of 2 plus or minus the square root of 2 divided by the square root of 5. I hate having an irrational denominator. It's just a no-no in mathematics. And so I could multiply by the square root of 5 in both the numerator and the denominator. And so x is going to equal plus or minus the square root of 10 divided by 5, and I can go to a calculator at that point. Okay, and I'm not going to show you, I'll just do it really quick. The square root of 10 divided by 5 is going to be about 63/100ths, and then the negative of the square root of 10, which should be just the negative version of it. Yeah, negative 63/100ths. All right, so that's how to solve it using equation solving skills. Here's a story problem. A ball is dropped from a height of 300 feet. How long will it take before the ball hits the ground? When will the ball be 50 feet off the ground? Well, to do a problem like this, I need h equals negative 16 t squared plus or minus v sub o t plus s. All right, and the initial velocity, since it's being dropped, v sub o is 0. All right, starting height is 300 feet, so s is 300, negative 16 t squared, and how long before it hits the ground? That's 0. Now, I can go ahead and use the quadratic formula on this. On this one, I don't think I'm going to, though. I'm going to use those equation solving skills. So I'm going to add 16 t squared to both sides. 16 t squared to both sides. So 16 t squared equals 300. I'm going to divide by 16. And watch this. I'm not going to simplify that. Now I'm going to take the square root of each side. All right, so I'm going to get t equals plus or minus the square root of 300 divided by the square root of 16. Well, I know that the denominator is going to be 4, right? Now I'm going to come over here and simplify this rad of 300. So let's see here. Rad of 300 would be the same as, I know 25 is going in there. How many times? Well, let's see, 25 goes into 100 4 times, so I think that's times 12. I didn't get the largest perfect square there, by the way. I'm going to have rad of 25 times the rad of 4 times the rad of 3. How did I get the rad of 4? Because 12 breaks up into 4 times 3. So this is 5, this is 2, and that's the square root of 3. So the numerator is going to be 10 times the square root of 3. Simplified is going to get me 5 square root of 3 divided by 2 plus or minus. Now the negative time won't mean anything to me, so I'll ignore it. So I'm going to do 5 times the square root of 3 and then divide that answer by 2, and I'm going to get about 4 and, excuse me, 3/10 seconds. Sorry about that. All right, so the time is going to be approximately 4 and 3/10 seconds. That's how long it's going to take to fall. That's part A. Now, I could have done quadratic formula and I'd get the same thing. All right, the other question is, when will the ball hit the ground? Well, the ending height, when will the ending height be 50? Well, it'll be 50 feet off the ground. So that's going to equal the same equation, only with a 50 over there. What was it, from 300, I think? Right? Yep, 300 feet off the ground. Okay, so it's got to equal to 0, be equal to 0, so I'm going to do negative 16 t squared plus 250. And on this one, I'll go ahead and use the quadratic formula so you can see it in action. So A is going to be negative 16. B is going to be 0. Why? Because there's no t term. And C is going to be 250. So t is going to equal 0 plus or minus square root of b squared, which is 0, minus 4ac, and that's all over negative 32. All right, so t is going to equal, I'm not going to worry about the 0, plus or minus, let me see here, 250 times 4 would be 1,000, yes? Now I have to double it 4 times, so that would be 2,000, 4,000, 8,000, and I think 16,000. I think it's going to be 16,000. Let me just double check. 4 times 16 times 250. Yeah, 16,000. So now I need the square root of 16,000. I got a feeling, oh, never mind. Negative 32. So I'm going to go to my calculator. I'm only going to worry about the negative square root on this one. If I do the positive square root, I'll end up with a negative answer. For a time, that doesn't make sense. 16,000 divided by negative 32, and I end up with about 3 9/95 of a second. Okay, so almost 4 seconds. So 4.3 seconds to hit the ground, and 3.95 seconds to get to 50 feet, to drop all the way down to 50 feet. All right, so let's see what else we got over here. A rocket being launched off a 15-foot platform with initial velocity of 250 feet per second. How high does it go? How long does it take to get to that height? When will the rocket be 100 feet off the ground, and when will it hit the ground? So, again, it's all about that equation. So, let's see here. H equals negative 16 t squared plus 250t. Is it launched off the ground? Nope, 15-foot platform plus 15. All right, question A is all about the vertex. So the first thing I'm going to do is find the x coordinate, or excuse me, the t coordinate of the vertex, negative b over negative 32. And when I simplify that to 32, I get about 7 8/10 seconds. That is the answer to the second part of A. Now to figure out the first part of A, I'm going to use this decimal, because when I punched in the calculator, that's what it gave me. So I'm going to go to the calculator and go negative 16 times the quantity of 7.8125 squared plus 250 times the quantity of 7.8125, and then I'm going to add 15. So H is going to equal that. Now I'm just going to go to my calculator with that, and I'm not showing you. I think you should know how to do that. Just to save time, I'm just typing it in. Plus 250 times 7.8125 plus 15. And I get 991.6 feet. So the height will be 991.6. That's rounded. That is the maximum height. So that's the answer to the first part of A, and it'll take about 7 8/10 seconds to get to that height. All right, when will the rocket be 100 feet off the ground? Well, same equation, only I make H 100. And so I'll have negative 16 t squared plus 250t plus 15. All right, so I subtract 100 from each side because I want it equal to 0. Why do I want it equal to 0? Because it's a quadratic. I want to use the quadratic formula. Quadratic formula finds me x-intercepts. That's why H, or in this case, it finds me t-intercepts. And that's why I want it to be H to be 0. All right, so let me just crank the discriminant out here really quick so I can save myself some time later. Just doing the discriminant. You can go ahead and do it with me. All right, I'm getting a discriminant of 57,060. So to find out when it will be 100 feet off the ground, I'm going to use the quadratic formula. T equals negative b plus or minus the square root of the discriminant all over 2a. And so I'm going to have negative 250 plus the square root of 7060. And I divide that by negative 32. And then t is going to be about 0 and 3500 seconds. I rounded to the nearest hundredth. That's one answer, but I've got to find the other answer because it's going to hit 100 feet on the way up. It's going to go all the way up to 900 some feet and then come back down. It'll pass 100 again. And the second time will be at about 15 and 28 hundredths seconds. And there we go. There we go. All right, finally, C. When will the rocket return to the ground? Same formula, only h is 0. So 0 equals negative 16 t squared plus 250 t plus 15. Again, I'm going to crank out the discriminant really quick. Should be really easy to do this. Boom. Okay, my discriminant is 63,460. So I'm going to go t equals negative b plus or minus the square root of the discriminant, 63,460, all over 2a, negative 32. And so, let's see here, 63,460. Okay, one answer is going to be about 15 and 68 hundredths. So t is going to be about 15 and 68 hundredths. And then the other answer will be a negative, which I'll ignore because it's 15 feet off the ground. So the other time it hits 0 would be going backwards in time. So that's irrelevant. All right, that's it. Level 2, you can stop watching here. Honors, I want to talk about completing the square really quick. So remember that to complete the square, we're going to force our trinomial to be a perfect square trinomial. First thing I did was subtract 1 from each side. Okay, and I put those blanks in there. Now, I take half of this and square it. The left-hand side just became a perfect square trinomial. I have to add 9 to the other side, otherwise I change the equation. So this will be x plus 3 quantity squared. That'll equal 8. Take the square root of each side. I'll get x plus 3 is going to equal plus or minus the square root of 8. And then when I subtract 3, I'll get x equals negative 3 plus or minus the square root of 8. And there you go. That's the exact answer. On this one here, it already equals 18, but I don't like the fact that a is not 1. So I'm going to divide through by 3. And so I'll get x squared plus 4/3 x plus the blank will equal 6 plus the blank. All right, so I'm going to take half of this, which would be 4/6 or 2/3, and squaring 2/3 will get me 4/9. And then I'm going to get 4/9 over here. All right, so this is a perfect square trinomial, x plus 4/6. If you want it to be 2/3, you go right ahead and turn it into 2/3. All right, 6 plus 4/9 is going to be 6 and 4/9, but 54, 58. How about 58/9? All right, I take the square root of each side, x plus, I'm going to simplify that, 2/3, and that's going to equal plus or minus the square root of 58/3. All right, so now I'll have x equals negative 2/3 plus or minus square root of 58/3. So x is going to equal negative 2 plus or minus square root of 58. Whole thing is over 3. Now I should check and see if that 58 can be simplified. I don't think it can. 2 and 29, there's no perfect square factors in there. All right, that's completing the square. Those are exact answers. You can use your calculator to turn them into decimal approximations. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.